What do you mean by solution of a differential equation? What do you mean by solution of differential equation? Meaning of solution of a differential equation. Meaning of solution of a differential equation. What do you mean by solution? Very important to understand that. Okay, a differential equation, DE, when I say differential equation, okay, differential equation in general, in general can be written as, can be written as y, or I'll write it like this, dy raised to n divided by, sorry, dn dx raised to n plus d of n minus 1 of y. I'll write here. Wait a minute, wait a minute. It's not done. I'll write a1. Don't write. Let me finish it off. A1 of x plus. See, I'm writing from my memory. Not memory, just like that. I'm writing in general. So I'm making it up now. N minus 1 y by dx n minus 1 plus so on up till plus a n minus 1 of x into dy by dx plus a n of x, a n of x plus a constant is equal to 0. This may be a differential equation. Okay, in general can be written as this. Okay, write this down. Okay, now you can write. Okay, so differential equation can be written like this. The solution of this one, the solution of this differential equation, solution of this differential equation is of the form y is equal to f of x, y is equal to f of x plus some constants, y is equal to f of x plus constants, the number of constants which can come. Okay, sorry, let me not write it like this. Let me write it f of x comma constants. Okay, these constants are arbitrary. These constants are arbitrary, and the exact value of these constants, exact values of these constants depends upon initial conditions, or boundary conditions. Initial conditions or boundary condition. This you write equation 2. Equation 2 with arbitrary constants is called the general solution, of the differential equation. Is called the general solution of the differential equation. When these arbitrary constants are there, it is called the general solution of the differential equation. When those constants are determined by applying boundary conditions or initial conditions, you get particular solution. I'll write this down. I hope you have written this down. Write this down, whatever I have written. I hope you have finished. After that, I'll go to the next, because for me, your notes to be nice is also important, because I don't give you any typed notes. So this notes has to be clear cut. Okay. Although I will give you a bit, but not fully. Okay. Give you questions, a lot of questions I will give you. This time I'm going to give, not like last time where I couldn't give. This time I'm going to give you printed, what do you say, question papers for practice. Last time I did not give you questions for practice. This time questions of practice will be very high. I'm starting it now. Practice questions are very important for you. I will get it from various sources. Okay, so I'll do the practice question system. Okay, done. General solution of the differential equation. Always make a delay in writing. Okay, don't write it along with me. Why do I say that? Because in between you'll get time to think. Otherwise, what happens? You don't get time to think, and thinking is very important here. When you think, you ask questions. When you don't think, you cannot ask questions. And I will complete the syllabus fast, but nothing you'll understand. That should not be the way, is it not? Sure. This is called the general solution of the differential equation. Okay, done, everyone? So now, if the exact values of arbitrary constants are determined using the boundary condition or initial conditions, conditions, the general solution solutions becomes particular solution. Particular solution means particular to that boundary conditions. Okay, particular solution is particular to the given boundary conditions or initial conditions. Keep in mind, boundary conditions and initial conditions is not the same. Those are two different things. What is boundary condition? What is initial condition? So you will understand. For example, let us understand with the basic example. This we have done a lot of times, but again and again we will solve this so that we get it through that example. One of the simple example we have got is d square y by dt square is equal to minus g. This is what? This is a differential equation. Correct? This is differential equation governing free fall. Differential equation governing free fall of an object, not of a object, because of O is swara, not vyanjana. So whatever swaras will come with an, correct? So an of O object. Okay, a e e o o object. Correct. So an object. Huh? Yes, please. In him. Object ಹೇಳುವುದನ್ನು object ಅಲ್ಲ, O ಅಲ್ಲ. ಓ ಅದು ಸ್ವರ ಅಲ್ವಾ? ಅ ಆ ಇ ಈ ಒ ಓ ಎ ಎ ಐ ಒ ಓ ಔ ಅಂ ಅಹ ಅಲ್ಲಿ ತನಕ ಸ್ವರ. ಮತ್ತೆ ಕ ಖ ಘ ಗ ನ ಇಂದ ಅದು ವ್ಯಂಜನ. Vyanjanas are consonant sounds. Swaras are vowel sounds. Okay, this is my theory. Don't tell this to anybody. Okay, say that my sir was telling there was a great theory and all those things. It is for you to understand. Tell in front of them, sir, vowel sound. A, I, U, A, O, I, O, A. They're all vowel sound. You will say yes. Okay, they have their own ways of telling. I do not know what it is. Okay, but keep in mind this works. Okay, so differential equation governing free fall of an object. Okay, so now if I want to solve this differential equation, what do I do? First integrate. Integrate. When you integrate, you get dy by dt is equal to minus gt plus a constant c1, which is arbitrary constant. c1 is a arbitrary constant. Again integrate. Again integrate. Again integrate. When you integrate again, you get y is equal to minus gt square by 2 plus c1t plus c2, where c1 and c2 are, what are those? Those are arbitrary constants, where this is the particular solution. So this is general solution. This is called the general solution with arbitrary constants, C1 and C2. C1 and C2. Now, what does that mean? That is understood further. Okay, just like that, the governing equation we have is not enough. You have to understand it further. Okay, let's understand using a graph. Because until we write the graph, we don't understand things. You have to write the graph and understand. Always higher level understanding comes from clear basic understanding. If Kohli can play shots very nicely, his basics are strong. Because his basics are strong, he can play things nicely. Wherever you go, your basics being strong is a much bigger advantage. Always keep in mind. To make your basics strong. Okay. Bharat, I'm happy that you're writing questions neatly. I want your notes. Okay, I keep the notes, everybody's notes I want to keep. This year this was the note, this year this was the notes. Okay. I'll take a Xerox and keep it. Okay. Bharat's handwriting is very nice. Chains I had to take, I'll take it from him. I have to Xerox and all those things. Bharat writes it. Super. Fantastic. His handwriting is much better. Okay. Show me. Give it to me. Yeah, somebody else has come. Pass it on. Hey, no, yeah. Not as good as his. It's good. I'm not saying it's bad. It's good. It's better than mine. Much better than mine. That's for sure. Welcome, Akhtar. So, yeah, you show yours. This show it here. See, here's handwriting. It's clear. Is it not? Which is better, ma? Which is better? This is better or that is better? This one, is it not? Which is better, Divya? Is it not? Ah, that's good. This is this is what happens. See, this is something to be laughed on. It is not something to be. See, you said that side is not good, sir. This side is good, right? This is something to be laughed on. Okay, but there are some professors in us who gets angry on us. ಇಂಥದ್ದು ದೊಡ್ಡ ರೀತಿಯಲ್ಲಿ ಇದು ಬುದ್ಧಿ ಖರ್ಚು ಮಾಡ್ತೀರಾ. But that has to happen naturally. Okay, that's why mechanical is bad because we think in this fashion. Okay, so some people from other side, like your circuit branches, they are very fed up with mechanical students. because each time they come, they answer these kind of questions. Okay, mechanical professors are never bogged down by this. Because we love that. Okay, because we were also like that. So no difference in that. Okay? Anyway, so general solution with arbitrary constants C1 and C2. Correct. Now, these arbitrary constants C1 and C2. How to find out? You have to find using initial condition. So now let us see what do you mean by arbitrary constants here. So I'll put a graph here. So let us say this is y, this is time t, this is time t. So what is that? It is a second order equation. What is the equation we have got? We have got y is equal to minus gt square by 2 plus c1t plus c2t. C2, is it not? Now, if you put C1 and C2, let us understand this, okay? When you put a t square, when t square becomes much, how it happens? Y is, it is coming below, is it not? Y is high initially, later on it reduces. That's how it is it not? So what is happening? Y, whatever the initial one, says this is C1, this is C2, arbitrary constant. From C2, the Y is reducing, observe. As t increases, y reduces. How it reduces, how fast it reduces, it depends on its slope. And that slope is a C1. Where C1? Initially C1, not later on. Higher the C1 slope means higher the velocity, initial velocity. If the initial velocity is 0, what is the slope of this curve? Slope of this curve is velocity. dy by dt is velocity. Is it not? So slope of this curve is velocity. More the slope, more the velocity. Correct? Am I correct here? I'm not. This is not the type of curve. This is not the curve. How the curve should be? Is this the curve? Is this the curve? Is this the curve? Write the curve of gt square minus c1t plus c2 with the time. It depends. Put an arbitrary one. I'm going to give you a shape. It depends on c2. C2 is this length. Yes, fine. But it's falling down. Huh? It can be 0. If it is 0, then what happens? It goes down. Minus. That's it. Yes, Chetan, tell me what is the curve? How is the shape of the curve? Huh? That's correct, parabola. But how the parabola comes? Parabola can be written in a number of ways. Which way I can write? Is it this way? I'm not talking about origin. Here, this is not the origin. You have C2. This way? Is it this way? Is it this way? Option 1 is this. Option 2 is this. Option 3 is this. Option 4, yeah, option 2, option 4 can be this. Which option? Or a parabolic curve. Come on, fast. Think. Don't close your minds. Attar, which one? Attar ji.
Option 1.
Option 1 as per Akhtar. Let us put a vote. Okay, one vote is for option 1. Okay, anybody wants to vote? We will see democracy here. Option 1, second vote. Oh, it's on a lead. Option 1 is on a lead. Others. Option 3 by this one, is it not? Option 3. Okay, one vote by Sagar Bangera. Then others vote. Voting is very important. I don't know. Tell me what is answer. Consider anything. 1, 2, 3, 4. How you have got to the answers, we are not worried. Option 1, by our Chetan. Yes, next. Nitin. Nitin ji. Kirtan.
Maybe two, sir.
Huh?
Maybe two.
Okay. 2 by Nitin. Fine. Then. Huh? 3. Okay. Then how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 3. We need 12 votes. There is only 1, 2, 3, 4, 5, 6, 50% vote. Others, please think. I want you to think. This is coaching. This is not teaching. There's a difference between coaching and teaching. Coaching is when a person is doing for running coaching, he is made to run. Correct. So here you are in thinking business. You are made to think. Yes, young man, tell me. Yourself, don't see back. You are the youngest man here. Tell me. I don't know. It doesn't depend. 1, 2, 3, 4. It's a multiple choice. Answer change ಮಾಡ್ಬೋದು. Okay, you can take it. Which one? Party बदल कर सकते हैं अभी. हाँ. ಮಾಡಲಿಲ್ಲ. ಸರಿ. ಡಿಸೈಡ್ ಮಾಡಲಿಲ್ಲ. ಮಾಡಿ. Sharan, still. Huh? You gave one. Okay. Women power. Where is it? Huh? Third one. Okay. So women has to get 33% reservation. So should I increase more number? No. Yes, tell me. First. 1. Oh, very good. 4. Okay. So 1, 2, 3, 4, 5, 6, 7. Who did not give? Youngsters are not giving their opinion. Nihal, still thinking. Okay. Bharat, you have to give the answer. No, it's mandatory voting. Ten. 1. 9. 8. 7. Kirtan. Kirtan ji, tell me first.
Sir, I give it as two, sir.
2.
Two.
Okay. 2. Okay. 2 is the answer. Okay. Another. 7. 8. 6. 5. 4. 3. 2. Gendina party. Yours is Gendina party or what? Okay. Majority is over. So this is the winner. Okay. And that is the right answer. Why right answer? Why 1 is the right answer? Okay. Why 1 is the right answer? See, velocity, initial velocity, if you consider. Initial velocity, what is velocity here? dy by dt. If this is horizontal, means dy by dt is 0. It is left from dy by dt is 0. That means it is left from rest. This particular thing, this is the object which is left from rest, then dy by dt is initially 0. What is 0? The slope of that curve. Where does it start from? Two things. One is position, one is velocity. Okay, and the curve is parabolic. So as it comes down, it accelerates. Yeah, as it accelerates, the velocity inclination or the velocity slope increases. So that is increasing in one. It's increasing in two also. But what is happening? It cannot go up. It would have gone up if it is plus gt square. If 2 would have been the answer if it was plus gt square. It's minus gt square, that's why 1 is the answer. I hope you're getting the point. So what has happened here is you write this down and say the slope is 1. Okay, then again you'll write it. Okay, because this is understand which is important, which is the what is the curve. See, as when time is equal to 0, when t is equal to 0, when t is equal to 0, c2 is dy by dt, which is equal to velocity. Always keep in mind velocity keeps on increasing. What is velocity? It is the slope. Initial velocity 0 idre undu vele this will come like this. If the initial velocity was 0, then it would have come like this, straight horizontal. This is initial velocity being 0, horizontal and then parabolic. If initial velocity was not 0, first not horizontal and then parabolic. It may not touch like this. It will, if it touches like that, then it is infinite. Never it touches like that. It doesn't touch here at 90 degree. Keep in mind, never. Because if it touches 90 degree, it's infinite velocity. This line touches this at 90 degree, like this. This is t-axis. It means velocity is infinity. The slope becomes infinity, is it not? dy by dx. Yes. Correct. Agreed. This is how you have to understand graph and mechanics. Together you have to understand. And differential equations gives us a input to understand these things. Should not take any things as just like equations and substitution. You have to think how it is happening. Only then the design understanding will come. Only then you are required by a company. Or you can do something new. Otherwise, what happens? Gumpalli Govinda. You should not become Gumpalli Govinda. You should become a leader. You should lead this one. If a leader has to come, he has to get the KIOCL internships. Congratulations, Shane. Okay. Yesterday he had a resurrection. You know, yesterday was Easter and he had a resurrection yesterday. All the best, man. Hopefully, our Apex will also have a resurrection. Okay. You know what is resurrection? On Friday, Good Friday, he was put on the Good Friday is on last was Good Friday, is it not? So on Good Friday, Jesus was put on the cross, and on Easter day he came out. He had a new life. Resurrection was there. That's what is believed. Okay, so that is how the things happen. Okay. That's why Easter is celebrated. Okay. Anyhow, chalo. What is the equation for 3? Equation for curve 3. It can be. It is not this. That's for sure. It is 1 by x. It could be. Huh? Plus gt square by 2. No. No. gt square by 2 plus gt square by 2 is 2. This is 1 by x type of curves or e power minus x curves. These are e power minus x curve. This is C2 minus e power 1 by e power x. What acceleration point? Acceleration is constant. It is rate of change of velocity. What is acceleration? It is rate of change of velocity. So if I had another curve like this, with this being t and this being dy by dt, if that was the case, then how it would be? This would be like this. Initially 0, later on increasing. And what is the slope here? Constant. Correct? So actually, would it be the way how it goes? Yes, no? dy by dt increases. But in which direction? Minus. So what should happen? It should, yeah, correct. Okay. T increases, dy by dt increases. Minus dy by dt. So what should happen? This dy by dt increases. I'm sorry here. Okay. This should be not like this. It's a wrong representation. The actual representation would be like this, because it is minus g. It's a negative curve. Slope should be negative. This is the wrong answer if I put it like this. It should be in the negative. This is dy by dt. Okay. This is dy by dt. Write this also together. Understand, understand. More than writing, understand. Okay. Because whatever writing goes off. But whatever is in the mind, what is registered in the mind, writing you have to do. Why? Again and again, cementing it, concreting it. ನೀರು ಹಾಕ್ತಾ ಇರಬೇಕು ಯಾವತ್ತು ಆಯ್ತಾ ನೋಡ್ತಾ ಇರಬೇಕು see we are doing tapas there are some people I like a lot in any what you say any talks in my class a lot of people I know on this tapas I want to get I don't know no tapas till now okay a chetan is required always if you don't have chetan then you're gone you should have motivation chetan is what motivation chetana motivation correct chetan is there although chetana is not there chetan is there so that is it another one I need is shreya then priya you know what is shreya and priya shreya is good priya is what you like to do you have to choose always shreya over priya and the person who chooses shreya is a viveka what he has viveka he has nice this one see gate now okay is difficult going to a software job is the easiest thing to do writing gate again is very difficult okay you have to prove yourself but it is shreya in the long term priya is directly joining a software firm because easily we are getting python you do it 3 months course you'll get it but it is not shreya it is not good it is priya it is nice I can tell somebody that I'm so like Nihal has done he has spent now he'll be spending around 1.5 years why he has viveka he has chosen shreya over priya okay then another person I need riyaz this riyaz is very important for me why riyaz is important you have to practice if riyaz is not there what is the use so shreya priya riyaz and there is one person I always want to put out of the class is aviveki aviveki should be always out of the class correct only viveki should be inside correct anyhow chalo these are all time pass things but very important okay so we have motivation today don't worry chetan has come to the class okay chalo done written down everything everybody let them finish and the person who is capable so, why did I say capable I was telling you name okay I did not understand. You got took time. Samarth means what? Capable. Okay. So he practices all those things, then he'll become Samarth. Okay. So, shall we go next? Okay. Next. Now here, you could have chosen anything. C1 could be anything. When you say general solution can be anything. It shows only the curves like this. This is general solution. These are general solutions. I'm sorry, not like this. Very sorry. This is general solutions. One solution here, second solution, third solution, fourth solution. General solution is infinite number of solutions. And particular solution, you are picking a solution. Understood? General solution, general shape of the curves. That is what is meant by general solutions. What we did here was general solution. We have fixed the shape of the curve. That means we have got the shape. Now we have to fix it somewhere. When we fix it there, then we get the particular solution. General solution, particular solution. Particular solution we get when we fix it. How do we fix it? We have to say the boundary conditions or initial conditions. Make sense? Clear? Now, here to solve this question, okay, we can use two type of conditions. We can use initial conditions, we can use boundary conditions. Both we can use. How? Let us see. So have you written this? These are general solution. Okay. These are all general solution. General solution, a lot of things. From this point only C2 is there, you can have a lot of solutions here. Depending on the initial velocity. If the initial velocity is 0, it will go like this. If it is initial velocity is upwards, it can happen that it is upwards, is it not? So it can have like this. This is C1 fixed. For different C2, we can have different slopes by which it is pulled. If there is an upward push, somebody is pushing it upward, then what happens? It will go like this, and then it will fall like this. Correct? See how strong this tool of differential equation is. That is why whenever you say something, you say governing equation for this one. Why do you put that governing equation? Why do you do that mathematical modeling? The purpose is this. Mathematical modeling is done for this reason. Wherever you go in R&D, you have to do more mathematical modeling. Today, why do you blame all these doctors that they are not proper? Once they say something, once they say something else. Or almost most of the things they do by experience, skills. Why is that? Human body is not mathematically modeled. Human body is not mathematically modeled. Next application of artificial intelligence and machine learning and our understanding of physics will be there in medical research. And all these costs will reduce drastically. Why it will reduce drastically? Because the whole human body will be mathematically modeled. So what you have to do, you have to go in a scanner and whole body mathematical modeling will be done. What are the mathematical modeling you have to do? You have to do fluid mechanics of the veins, heart, pumping power, mechanical engineering, pumping power, okay, what is the lungs, how much it takes air, what is porosity there, what is the amount of what I say amount of cleaning it is doing, what is the PMM it is having a what is it particle PMM, you know, particulate matter, I don't, it's particulate matter PM per million, yes, particulate matter per million. Huh? That is ppm, parts per million. This is particulate matter per million. Okay, it means it shows in environmental, you have that, is it not? You have to know what is the amount of ppm. It is part of civil engineering syllabus. So how much micron dust is there? More the micron dust is there, more thing. Then what are the other things which are there? NOx, NOx. Okay, NOx is one of the main pollutants of air pollution. Correct. Then, huh? SOx. Then sulfur dioxide, sulfur dioxides, sulfur oxides, nitrous oxide, and then CFC. CFCs now it is less, but CFCs are also one of the things. But now all of them have come together. And which was that particular place? I think Hague, I suppose. I'm not sure. Yeah, everybody met and said we have to stop CFCs in refrigerants. I don't know where is that. Quiz master? Don't know. Don't remember. Huh? Ozone ಅಲ್ಲಿ ಹೋಲ್ ಇತ್ತು, ಆ ಹೋಲ್ ಬಂದಾಗಿದೆ ಈಗ. The whole ozone layer, there was a hole in ozone layer above which place? Above North America, correct? Correct. Then where? Antarctica, correct. It was over Antarctica. Okay. Over Antarctica there was a big hole as big as the Americas. Okay, and then it was filled. That is because everybody stopped using chlorofluorocarbons, okay, which are problem for ozone gases. Fine, that is done. So we have understood what is general solution, correct? Now particular solutions we will understand to the depth. Wait a minute, wait. Come back, come back, come back. Change, you have to involve me to the discussion. Okay. Otherwise, you know how jealous I am. Okay. Fine. Next part. Okay. Next part is this. Just a second. Okay. So yes. So this is about general solution. Now, which downwards? Yeah. Okay. Between what and what? 1 and 3, because we know this slope. What is this slope? This is velocity. Velocity initially is less. As you grow, velocity becomes more. So here in this 3, what is happening? Velocity is becoming less. No, yeah, that's how we have to get it. But this curve itself will suggest that. Why? Because this curve, when you consider dy by dt, what you will get dy by dt? Minus gt plus c1. What is gt? You get minus here. That means change in velocity, change in position. Okay, not just like that. It is because when t increases, dy by dt magnitude increases. It can be got from this only, nothing else. When time increases, dy by dt increases. Is it not? Make sense? So from this only we can get. We need not see anything. Everything is in the equation. That's why mathematical modeling equations are put. Once equation is done, ಅದರ ಜಾತಕ ನೋಡಿದಾಗೆ ಎಲ್ಲ ಗೊತ್ತಾಗ್ತದೆ. We understand everything from the equation. It is like a horoscope. Sorry, horoscope. Okay, chalo, next. I do comedy, but don't fall into the comedy. Okay, it is like through comedy I am making you to understand. Very important. Okay, so you have to understand the bigger things on it. Okay, fine. Now, wait a minute. Next one. Okay, now we can find the particular solution if I say first type of first type. Okay, I can say that the conditions, I am not saying boundary or initial, the conditions may be at t is equal to 0, t is equal to 0, y is equal to 50 meters, okay, and dy by dt is equal to say plus 1 meters per second. Now this way when I put at t is equal to 0, okay, this means I am doing the initial conditions. Initially, what is it? That's what I am telling. But it does not depend on time. It need not be just time. It can be dy by dx. It can be dy by dx instead of dy by dt, in case it was dy by dx. Here we have, in this particular one, it was time. So this type of thing where you have at a particular position, don't take it t as time, take t as a coordinate. At one coordinate, you are telling its value, one value, and the derivatives of that value. If that is told, such kind of conditions are called initial conditions. So I can say this and I can find the arbitrary constant, is it not? So putting this, I can find the arbitrary constants, is it not? Okay. So applying dy by dt is equal to 1. That is what? It is minus gt plus c1 at t is equal to 0. Means what? T has to be 0. That means what? C1 is equal to 1. What am I putting? C1, the condition is 1. Correct? Next, similarly, applying y is equal to 50 meters at t is equal to 0. What will I get? I will get y 50 meters is equal to minus g t square. That means t is 0. 0 square by 2 plus c1 into 0 plus c2. So what did I get? C2 is equal to 50 meters. So what is my particular solution? The particular solution, the particular solution is y is equal to minus gt square by 2 plus 1 t minus plus, this is the particular solution. What was the general solution? C1t plus 50. C1t plus C2. This would be the particular solution. Now this way of putting is called initial conditions or initial value problem. This way when I specify, it means initial value problem. Next topic I will do initial value problem, then type 2, which is boundary value problem, which I'll do next. Make sense? Slow and steady, but the depth. When you understand like this, there is no way that you can fail, provided you revise again. And this time I'm going much deeper than last time. And I'm not using any textbooks. I'm not using, I have referred textbooks, but everything is mine. The way it is going is mine. Right. It is based on whatever gate till now, how it has come, and what I've got experience by teaching students. Okay. So like that I'm changing. So I know when something is told, students did not understand. So what I'll do, next time I'll change the way, so that the next time the students will understand. And this experimentation continues. It's a continuous experimentation. Okay. That's how pedagogy is developed. You know what is pedagogy? Teaching style. What has to be taught first? What has to be taught next? That is what is called pedagogy. Vocabulary building. Because vocabulary is also part of the game. Okay. So you can write this somewhere. Pedagogy. How do you teach something? Check the meaning, check the spelling properly. Okay. Aside, you can write this pedagogy. Okay. No? Wrong. So properly is wrong. Let us see. We have Google Baba. Let us ask Google Baba. Pedagogy. Yes, it's pedagogy. What is it? The method and practice of teaching, especially as an academic subject or theoretical concept. How to teach, that matters. Okay. Fine. Anyway, next. So this is called the particular solution. I hope it's clear. Next. Now, oh, keep everything. Do not miss anything. Control C, Control V. Let us delete this, and then again we will say Control C, Control V. Few more. So now further. Now we define what is initial value problem. Initial value problem. Select a general solution to the differential equation one. We have defined one there. Remember, we have defined differential equation one there. Okay, for the differential equation one can be given as let be given as say C1 y raised to n plus C2. Okay, wait, no, not like that. No. dy by dx, is it not? So dy by dx, if you have, what is it? What is the particular? So dy by dx. So what you have, you should get y as a function of x. So let it be that the general solution of equation 1 can be given as x raised to n c1 into x raised to n plus c2 into x raised to n minus 1 plus c3 into x raised to n minus 2 and so on up till plus c n minus 1 x plus cn is equal to 0. Getting that? Everybody understood why did I write this? Here in this case, I had second order differential equation. When I used second order differential equation, I got in the square. This is C1 is minus G1 by 2, minus G by 2. Y2, C2 in that equation was C1. C3 in that equation was C2. Make sense? So when you have equation in terms of dx d raised to n by y, what you will get? You will get in terms of x raised to n. Make sense? Write this down. Correct? Understand this. How did this come? This is what is theoretical. Theoretical has a people sometimes say theory is not required. Theory is pustaka badane kai. Agar pustaka ya bari udo. Why theory? Through one theory, the theory has been developed by a lot of practical knowledge. Theory did not come just like that. If you go for practice and you say you go directly to this one, you will not get it. Agreed that without practical knowledge, theory is nothing. Without practical understanding, theory is nothing. But practical knowledge, you will again have to go from Euler. If you want to start like another 300, 400 years, you can come to this level. What you have to do? You have to understand theory and apply in practice. So they say when you have to get practical knowledge means what? You should know how to apply the theory into practice. It does not mean that you don't need theory at all and only practice is everything. A lot of people who go to internship say that. Sir, the machine sir, outdated. You see in Quora, I see a lot of people putting mechanical engineering, civil engineering, these are outdated things are being put. There is a professor in IIT Kharagpur who has answered in YouTube. He has said that all these things are very much required. If you don't know this, you will not design any machine component properly. He was telling about theories of failure. There one BTech fellow was there in the third year, put in his YouTube channel, why these professors are doing this, all the music and everything, why these professors are teaching us von Mises stresses. He used that equation, von Mises stresses equation. He said, who is going to use this? Okay. The professor said in detail where it is used. You understand? These IIT Kharagpur professor. Okay. So all these things are very, very basic. No doubt, industry is much more advanced. We are not claiming that academics is much more advanced than industry. No, never. Industry is at a high level, but to understand that high level, you cannot be put directly to that high level. No doubt, Virat Kohli plays very nicely, but you cannot be Virat Kohli if you don't go from the basics. If you want to go to Virat Kohli, you cannot go with Virat Kohli as a coach from the initial. It is very costly, first of all. Second thing is that not required also. Okay. First, initially you have to go with a small coach, district level coaches. Then you grow. Similar way here also. You are reading here. Tomorrow he is going to KOCL. I saw his face and I can see only KOCL there. Okay. Okay. He is going to KOCL. KOCL, no doubt, is very good. Very big machines are there. But all the things what is being put here, that is being applied there. Nothing else. You'll see the applications. When the theory is strong, your applications is strong. Theory is weak, your practical is weak. Simple and straight. Okay, sure. Now, don't believe on anybody who says that whatever is there in mechanical or civil engineering, what we learn is outdated. It is not outdated. It's basics. Get the difference between outdated and basics. Okay, fine. So, huh? Yeah, why is it? I'm sorry. It is zero bad. I'll tappai. Why is it? I'm very sorry. It is not zero. It's y is equal. Correct. I'm sorry. My bad. Fine. Zero on the hat very. Y is equal to. Correct it, please. I did not think and I was just putting it. Because previous class was polynomials class for 10th standard. So in that polynomial class, I was doing this equal to zero. So that is what was the problem. Okay. It's inertia, you know. The body in rest or continuous motion stays in that state of motion until and unless an external force acts. Which law? Whom I am quoting? Newton's first law. Okay, so Newton's law applies to mind also. Okay, he didn't think about it. Okay, so done. So y is equal to c1 x raised to n, c2 x raised to n, all these things. Okay, if the conditions to solve for or to find arbitrary constants, okay, to find arbitrary constants c1 c2 etc up till cn are given as at x is equal to x1, y is equal to y1, at x is equal to x1, dy by dt, dy by dx is equal to y1 dash, x is equal to x1, same point, d square y by dx square is equal to y1 raised to 2 or double dash, and so on. Then the problem is a initial value problem. What is it? It is a initial value problem. It does not say about time. It is one point of x, independent variable. You are putting y, dy by dx, all the derivatives are set for that particular initial. Then it is called initial value problem or IVP. initial value problem, you can put IVP. So the example, previous example what we have given is an example for initial value problem. Yes. Initial value does not depend on time. Let us do a problem and see. We have to understand this. These are Park and this one exams, they ask these questions. What is initial value and boundary value? The initial value is for time t is equal to 0, sir. Boundary value is at two boundaries, sir. No, it's not like that. It's not like that. They'll put you into trouble later on if you say like that. Okay. Initial value problem. Then, second, for the type 2, first type is over, second type, second type, second type. Second type is for the freely falling body, falling body, the general solution, GS, the general solution is given by y is equal to minus gt square by 2 plus c1t plus c2. If the conditions are at t is equal to 0, y is equal to 50 meters, and t is equal to 1, y is equal to 45 meters. I can have that. I can have two conditions, but I don't know which will. Wait a minute. T is equal to 1, y is equal to 45 meters, and yeah, it's possible, is it not? We do not know the initial one. Okay, t is equal to 0, y is equal to 50 meters, and t is equal to 1, y is equal to 45 meters. Possible? It's correct. How it is possible? It's possible because we don't know the initial velocity. Okay, if you drop it directly, you'll have only one solution. But if you have an initial velocity being given, you can have any infinite values of t1 and t2. So if this is given like this, then what happens? Y1 is equal to 50 meters is equal to gt square, t is equal to 0, put that c2. So you'll have, I'll write it down, minus g by 2 into 0 square plus c1 into 0 plus c2. This implies C2 is equal to 50. You're arriving at the same number. Or no, C2 will be different. It is not the same number. C1 is coming the same. Then Y2 is equal to 45. That is equal to minus G by 2 into 1 square plus C1 into 1 plus C2 is known as 50. So using this, can I find C1? Yes, we can find C1. Tell me what is C1. And then I get the particular solution. Around 1 you get. 1 point, calculate it properly, no? Don't be lazy. Jadatva is something which is very bad, laziness. Inertia. Jadatva is, proper translation is inertia only. Laziness is alasya. Right? Don't have inertia. I know you don't have laziness, but don't have inertia also. If you are lazy, you will never be in gate classes, that's for sure. A lazy person will not be here. Correct. Samarth is finally, I don't know why. I did not refer to anybody. Yes, what is Seaman? 0. C1 is 0. No? G is 10 you are taking. Fine. What do you get C1 as? 0. If G is 10, you get C as 0. Okay, fine. So you get C1 as 0. Possible. It's possible. That means it is thrown with initial velocity 0. It is dropped. Correct? It is dropped like this. C1 is initial velocity. If initial velocity is not there, then what happens? GT square only will come, is it not? So it means initial value is 0. So what is happening? By arbitrary, I have given it and I am becoming right here. And yes, correct. I'm correct here. Okay. So 10% there is a decrease. Okay, 10% decrease. Maybe that has come. So what happens? C1 is 0. That means my particular solution is y is equal to minus gt square by 2 plus 50. This is the particular solution. Make sense? Write this down. Now we will see what is meant by boundary value problem. This one is the boundary value problem. Very, very important. Very, very important. We can do as much as solutions as possible, but understanding is important. Solution is about your practice, but for practice you need motivation, and that motivation comes to this one. So from now onwards you are starting. So half of the class is free. The class starts from 9 o'clock. Class starts from 9 o'clock, goes till 8 o'clock, 8 p.m. So you have to come here at morning 9 o'clock. Okay, ideally 9, or at least if you are at home, you have to start practicing from 9 o'clock. Okay, so 9 o'clock till 2 o'clock is your practice. Then 2 o'clock till 8 o'clock is your classes. That's how this will move. And when the next batch starts, suppose August or July, it starts. Hopefully, if they come in July, I'm very happy. Then what happens? Most of the students in the final years, after graduating, they will think whether to come or not to come, and they'll spend time there. I will take, not a trouble, but they have to get time to practice. And gate is the only way around. Let me tell you, if a person wants to stay in the field, doesn't want software, gate is the only way to go. Because some people may say there is this one person who has got into from other colleges, Might and other Saint Joseph also, your seniors, who have got into these. They have got campus selected into Robert Bosch, Volvo. Okay, a lot of people. Okay, what happens? Their improvement is not that high as Gate is. Improvement is less. They start now. They will start with 4.5. To get to 10, they will take at least 10 years. Until and unless they are exceptionally well, exceptionally good. There are candidates who get more than that, but it takes time. If you have an MTech degree, it becomes within, after you get the MTech degree, you get 10 plus only. From IIT, if you get, it is 15 plus. Okay, so very important. Okay, so next, what is boundary value problem? Let us do boundary value problem. BVP, boundary value problem. Boundary value problem. Now, if the solution, the general solution, if the general solution of the differential equation 1 is given 1 to c1 x raised to n plus c2 x raised to n minus 1 plus c3 x raised to n minus 3 and so on up till cn minus 1 x plus cn. The conditions, the conditions, if the if the conditions for finding, if the conditions for finding The arbitrary constants are given as at y is equal to, sorry, yeah, at x is equal to x1, y is equal to y1, x is equal to x2, y is equal to y2, and so on up till x is equal to xn, y is equal to yn. The problem, the problem is defined as boundary value problem. Boundary value problem, or BVP, for the boundary value problem. Whenever you see a differential equation, you have to see whether it's an initial value problem or a boundary value problem. Very, very important. Make sense? Understand and write. Everything, every derivatives are given. One value. Then there are mixed value problems. This is IVP, VVP, and a mixed value problem. At some places there is value is given. At some places there are derivatives given. Then these are called mixed value problems. No derivatives. Values. Boundary. At boundary, this is the value. This is the value. This is the value. Actually, in AutoCAD, if you have practiced AutoCAD, the various ways by which you can define a circle. One way to define is you have to put a point and a tangent. It's a second order equation. Okay, it's a parabolic equation. Your circle is a second order, is it not? So when you put a point and a tangent, you can define it. That is initial value. Or you can put sorry, tangent. When you say, wait a minute, no, 2 points and a tangent, I'm sorry, 2 point and a tangent you have to put. Then you get a circle, because you have x and y, two things are there, x square plus y square is there. Or you can put 3 points and then you define a circle. Okay, you can have two tangents and one radius to define a circle. If you go to AutoCAD, different ways of, have you gone to AutoCAD? In a circle, you have 9 types of defining a circle. Center, two sides of a diameter, you define it. Okay, center and radius you can define. Correct. Then tan radius, tangent radius. Okay, point and a center, point and a tangent, something like that. There are 9 ways. Previously, I remembered that because I used to do it on the board. Some people said that in Africa, a person was teaching Microsoft Excel by writing on the blackboard. The whole GUI he used to write in blackboard. The same thing I was doing with AutoCAD, but there was no person to click that image. Okay, so the whole graphic user interface of AutoCAD I used to write on the board. That was a way used in CAD Center. It's not mine. In CAD Center, initially 4 or 5 classes, they never asked student to touch the computer. It's all on the board only. Now I don't know whether they are following it or not, but at that time it was like that. Huh? ಯಾವುದು ಟಿವಿಯಲ್ಲಿ ಹೇಳಿದ್ರ ಅದನ್ನ? ಸರಿ ಸರಿ ಸರಿ. ಅಂದ್ರೆ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡಿ ಹೇಳಿ. ಹಾ, ಅದರಲ್ಲಿ ಆಟೋಕ್ಯಾಡ್ ಪ್ಲೇ ಮಾಡಿ ತೋರಿಸಿದ್ದಲ್ವಾ? ಇಲ್ಲಿ ಹಾಗೆಲ್ಲ ಬೋರ್ಡಲ್ಲಿ ಬರೀತಿದ್ವಿ. And they asked you to write on your book. That's important. Okay? It's very nice. So CAD Center does it nice. Any good thing goes from the very, very basics. When a person starts with basics, programming, basics, strength in the basics is very important if you want to go higher. Otherwise, you cannot grow. Keep in mind. Okay. Sure. Next one. Mixed value problem. Okay. Mixed value. Mixed value problem. Now you will write if the general solution of the differential equation 1 is defined as y is equal to c1 x raised to n plus c2 x raised to n minus 1 plus c3 x raised to n minus 2 and so on plus c n minus 1 x raised to n plus cn. Okay, cn cn then 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 okay, and sorry, cn and the conditions to obtain conditions to obtain the arbitrary concepts on arbitrary constants involve values and derivatives, values of the values of the dependent variable and its derivatives variables sorry, the values of dependent variables at some points, at some values or some what do you call, some locations and the derivatives of the dependent variables and the value of derivatives, very important, value of derivatives of the dependent variable at some other locations, then the problem is said to be a mixed value problem. MVP, very important. So that means at some, say y1 is equal to, at y1 for example, like y1 is equal to, or at x is equal to, say say at x is equal to sorry, at x is equal to x1, y is equal to y1, x is equal to x2, y is equal to y2 dash, at x is equal to x3, y is equal to y3, x is equal to x4, y is equal to y4 double dash, like this. And a lot of things, lot of places come different ways, okay, and so on, similar, okay, all the things arbitrary, okay. So if that way it is there, then it is a mixed value. So we'll stop here.